Okay, in this video we're going to be talking about the VPPM proportional valve from Festo, and this is the IO-Link version, and I'm going to discuss how to get this up and running and how to integrate it properly. Not all the files I'm going to show you in this video are going to be included with the download, but that's because they're in my own information. And let's just talk about something. So on the website, we navigate to the website, start our web browser here. Okay, we're on the Festo website. I typed in this part number here, which is what I'm using. Support downloads, technical documentation. We'll see here that the LK, which is the IO-Link portion, there's a variety of manuals here. And I have the user manual open right now. And this is the user manual here. And as well, we have the software section. And there are IO-Link IODD files here. For the Rockwell environment, this is not what is recommended for use. If you're going to use the VPPM in a Rockwell interface environment, then you need to contact technical support or include it in my download zip file link in this video. You will find that there are some special IODD files. And these files are for the premier integration of the Rockwell environment, which is basically the AOP enabled key is active. Okay, and if I show you the files, you'll see that you have this right here, and this file, the 2016-0405, will be the file that you want to use. Okay, so you'll register this directory in the Rockwell environment. So how do you register the file? Well, there's a couple different ways to register the IO-Link file. You can navigate to this directory right here if you have admin rights, and you can simply copy all those files. And for example, there's my files right here. Alternatively, you can, if you have IT problems, you can while offline, of course. Let's go offline here. You would make like you're going to add something. You come through here, you click on the button, you say register IODD. It brings up an interface eventually. And then you say register again. And then you pick where those files are stored. And you basically select the file, and away you go. So you would pick this file and say open, and it would simply register it. You don't get a notification or anything that it's done, it just happens. Okay, and then you hit exit, 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 cancel, and then you have the ability to add, so on and so forth. Okay? Okay, let's keep talking about the IODD file. So the next perspective is Rockwell IO-Link masters. And it's important to have an understanding of what the firmware is in your IODD, or in your Rockwell IO-Link master. I'm going to start up RS Links. Go to my device here, and we'll see here that this is what I'm using today, the 1732E-8IOL M12R. And go to module configuration, and I have Rev 3012 firmware installed. It's important to know that because regardless of this product that we're using, data storage only started taking place at a certain rev of the firmware. At the same time, you need to have an understanding if I use the .io I have, if I look at this one right here, for example, this 1011 does not even support data storage for any of your devices. Okay, So that's a really good point. The next point is add-on profile. So if you go to the Festo website, or not the Festo website, the Rockwell website, you can download what's called AOPs or add-on profiles, and it's important to match the profile. So make sure that the module profile is compatible to the firmware and at the same time compatible with what you want to have happen, like as far as the data storage goes. So this one is 30160, and I know for a fact that this supports data storage and so forth. The fact that we're talking about the VPPM, in this case, this right here, this particular device from Festo does not support data storage. Fortunately, Rockwell has a feature called ADC, or also known as automatic device configuration. And how do you get this to work? So in order to add a device, I'm just going to add a device real quick here. I would come through here, pick the device, and then I would come through here, valves, VPPM, and then I would pick a device. Okay, say create, and as it automatically puts in the enable ADC. In order for ADC to be functional, the device needs to support IOLink version 1.1, and you have to have exact match turned on. And this feature here, make sure you're not disabled, that it's actually enabled. Okay, so I'm going to show you the difference right now between a disabled and enabled, and let's just talk about this based upon Rockwell perspective here. So I'm going to say okay, yes. So I have, do I have the same device? Yeah, okay, good. So the first one here has the automatic device configuration enabled, and I have the additional tabs. Okay, I have the parameter access and so forth. When I have the automatic device configuration disabled, I do not have the tabs offline. Okay, this is a new feature with Rockwell, and it is how it is. If you have older firmware, and I'm just going to show you this real quick, or maybe I won't, hang on. Okay, let's look at this, and based on the version, so I'm actually using a very new version, 3301 standard edition. Based upon the version, I've opened up the 4IOL here, which has the older firmware in it. If you look at the general tab, it's the version here has to match the firmware. And when I go into IOLink and I want to add a device here, you select the device just like you did in the other one there. Same exact device, hit OK. Well, the fact that I want to point out is that enable ADC is not even an option. It's on all the time. And in older firmware, software, and so on and so forth, this didn't even really pop up at all. And what happened was when you navigated to the device, you automatically had these tabs here offline. Okay, so I just wanted to point that out, and just going to close that because I'm not using this right now. Make sure it's been closed. Yeah, so that's as much as I can tell you about the IOLink Masters from Rockwell and how the interaction works with the data storage and the automatic device configuration option. And the big difference between, well, I'm going to show you something here. So I'm going to change this device to something from Rockwell, for example. So depending on the device, you have additional options here, okay? And the Rockwell device knew that its only option was enable ADC because data storage does not exist on the VPPM. This case, this device from Rockwell or Allen Bradley, it does. So you have the backup restore or the restore option. And the difference between backup restore and ADC is the fact that restore and backup restore are IO-Link specification standards, or IO-Link standards. And they use system commands to store data to the IO-Link master itself. Okay? The Rockwell enable ADC option is a feature only offered by, or is basically unique to Rockwell, and it stores all the parameters, the same concept, to the controller and the offline project file. And anytime a device is replaced, it will download those parameters to the device. And I'm going to hit OK. And then I'm going to go back in, and then I'm going to delete that device and get back to business here. Just collect the device, hit the delete button, and done. Okay. So now we're back to a working project. So again, in order for these tabs to be available, you have to have enable ADC turned on. If you have the disabled turned on so that there is no data storage or automatic device configuration, then these tabs here, even though offline are not available, these will be available when you're online. Okay? All right, so by putting a VPPM in channel 0, automatically the tags are configured channel 0. It's called IO-Link. Then we have the pressure actual value, and then the output we have the set point value. And then we have diagnostic events. So let's talk about diagnostics for a minute. In the user manual, we have we have error numbers. For example, this, and then this kind of rolls over the top of the page, over here, and over here. Okay, so there's a variety of faults. And what I've done with my code here is I have used the events and an understanding of how the events work, and I am setting or resetting errors. Okay, so I'm just going to go online right now. Okay, so what I've done here is I have coded a variety of error codes. Okay, in the IO-Link master itself, we have a standard error code hex number 10, which is 16 decimal, and this will be triggered when you have a lost connection. And then this channel 0 fault or connection faulted, they kind of mean the same thing, which is a cable error. So right now, if I pull this connector cable out, then I have the fault active. If I connect the cable back up, and the fault goes away, so on and so forth. This fault right here, if I zoom in a little bit here, is for under voltage. I'm not going to trigger this one. That's basically when your voltage, supply voltage, I think, on the pin here, if I was to go to, I think there's a picture. No picture. I thought there was a picture of cable. Regardless, when the supply voltage is under 18 volts, then this event will be triggered. Let's look at these ones right here. So we have pressure set point less than configured lower limit, and pressure set point greater than configured upper limit. So if you go to the properties here, you go to the parameters, right there, this here is basically default. So this particular device right here has a pressure between 0 and 6 bar. So 6,000 represents 6 bar, and there's my limits. So if I give this something better than, because you have to be beyond the limit, okay, and I come through here to my process data, which I've coded, not much of a coding, but if I specify a value of 6001, then navigate to this, then I'm going to have my event code saying, hey, you're above your upper limit. If I was to type in a value of 0 now, then I'm below my lower limit. Okay? Next thing I'm going to do here is I'm going to put a value here that is really beyond what is allowed for that valve. And if I go to the diagnostics, you'll see here that this error code is triggered because an upper or lower limit is outside of the allowed range. Okay? Also, a good thing to note is that with the Rockwell environment, I could come in here and specify a 16 pound sign and then 8C42, which is the hex number. But this diagnostic code coming in as an integer, and the comparison does not seem to work. Okay, so I've used the decimal value so that it functions properly. And another point to make is, so I already have that fault right now. This fault exists. And I'm going to go back and I'm going to put a value of 0 right here. And you would think that you would get the lower limit, but it doesn't work that way because there's already an existing event. And the existing event is this. So this event has to be cleared before another event will be registered. And so I'm going to put this process value back to 1. And put this value back to the correct range here. And I go back to the diagnostics, this is off now. And again, if I go back to a 0, I should trigger the fault, which I have. Okay, so this one right here is the conditional counter limit. Inside the proportional pressure regulator, there is a solenoid valve, and this value right here, this is the largest, which is the default reset. If this is set to a 2, for example, when the solenoid has exceeded a cycle of 2, then you'll have that event triggered, and so we're not there anymore, and now we've exceeded the condition counter. Okay, so these are the diagnostics that are available with the valve. The code basically works here. What will we talk about next? Okay, next is some IO-Link system commands. So one of the commands that exists is an index 2 subindex 0, and then with that you send a command value equal to 82 hex, which is the restore factory settings. And this is not mentioned in the user manual, but if you open up the IO-Link specification, I've taken an excerpt from it here, and the so index 2 is the send system command, and the 82 hex is the restore factory settings. So if you navigate to here and we actually send this command, get the done signal. Now when we go back to the device, you will see here that it has reset the values in the device, and I'm going to take those values and put them in here and populate it, and then I hit apply. So that's the restore system settings command, factory settings. Okay, this IOLink parameters just talks about some individual read and write of index or subindex from the user manuals of Rockwell IOLink masters. The next thing, I'm going to close everything except for this. Actually, okay, so the next thing to talk about is the common tab here. So on this tab here, we have some information that may be of some value to you, like device ID, the vendor ID, which is Festo, IOLink version, so on and so forth. We can gather all this data by sending a message command. You have to be careful when using messages because they take up a connection, and some smaller PLCs from Rockwell only have so many connections. So in here, we're sending a index 0, attribute 0, and this allows reading of the common device data. Okay, this is again not in the user manuals, this is part of the IOLink specification. And again, I've taken the table from the IOLink specification here, and you'll see here that you get a variety of information. In the Logix PLC here, I do a read. It populates this data here. If I go to the data, I've labeled or given a description for each of these, and if you look at it in a hex value, oh sorry, not the individual one, the whole array here, there we go. And when you do that, then if you do a correlation of the common tab to the tags, then what you end up with is this little picture right here. So you have the device ID, which is the device ID, minimum cycle time, minimum cycle, revision, vendor ID, so on and so forth. So this matches everything, just to give you a little heads up. Okay. And the next one here is another message instruction to read and write the device parameters. Okay. And it's index 67, and we're reading and writing. And what we're doing basically is we're reading and writing these parameters in general, or a couple of parameters associated with that. To elaborate on that, if you go to the user manual, page 3, you'll see here that you have the parameterization here, and that you've got these are all the same. So it's modifying certain things here, and each one of those is described in detail within the manual here. If I come through here and do a read, then I'm using the response data to actively set my own data type to trigger and show me what is actively set when it comes to that value. If I further look at that in detail here, in relation to the user manual, you'll see here that hopefully you can see this, that there's a bit pattern in there in the user manual, and it shows you, if this bit's on, this bit's off, these are set, and that's all there is. I'm just showing there's a correlation here. So there's a unit of millibar, KPI and PSI, and so on and so forth. And then we've got the control behavior, which is universal, precise, or fast. We've got some smoothing if it was filter used. and an output signal, whether it be current value or comparators. And all of these here can be set in the interface itself. Okay, this is already set right here. So for example, you could set one of these right here. You could change the behavior right here, and you could set up whether you want diagnostics to be active or not, so on and so forth. So all of those parameters right here are accessible through message instructions once you've read the manual. Like I said right here, here's a couple other ones right here. I just haven't coded it. I'll leave it up to you if you want to go further with that. And the last thing I'll show you, I guess, is the process data and then the ADC function. So with the process data, like I said at the beginning of the video, you have a pressure set point value, and right now I am set for a millibar. The user manual will show you that millibar gives you a range. The OL6H is 0 to 6,000, which is 0 to 6 bar, which is the millibar here. And you get a actual value back. And if you read the user manual, you will see here, somewhere in here, it will tell you that, right here, you need an input pressure P1 of at least 1 bar above the output pressure P2. So in my lab here, I don't have a whole lot of pressure, so I'm just going to set a very small value here. I just have a cylinder that I'm working on here. So if I put a value of 500 and I give it some pressure, you'll see here that you get the 500 back. So if I have less than that, then you can see here that there would be less pressure. For example, 1000, I cannot even achieve the 1000 if all I can achieve is like this, because I've already lost some pressure. So that's important to understand. Finally, let's talk about the ADC functionality. Again, this has to be enabled right here. And what this does here is that anytime you make any change at all here, it stores this in the controller as well as the offline project file, of course, if you have to save. I'm going to go to system commands here. I'm going to reset the data on this device. I'm going to unplug this device and plug in another device. Reset the device. So this is what's in the universal. This is what's configured right now as far as all the parameters, whatnot go. And I'm just going to change these values here. Okay, hit apply. So what this just did is it saved all these parameters here to the controller. It's also saved in the project somewhere. Okay. And right now I'm gonna unplug the device. Okay. Device has been lost here. And now I'm gonna plug in the device which has factory settings that are different from what is there right now. And if I do a refresh, we see here that everything's been modified to what was modified on the previous device. So whenever you change the device, it will automatically download those parameters to the device. If I turn off automatic device configuration, then what would happen was when you plug in the device, whatever the parameters were in that device would be active and no download of anything would happen. And that's it for this video. I hope you've learn something and look for the sample code to go along with it.